Well, welcome to this tutorial about mathematical logic. First, we should know that p of x will represent a proposition. Remember that a proposition is any statement that can be proved true or false. Also, q of x will be a proposition. We should also know that this symbol here will represent and. You can see it resembles an A without this little stick here. And the other one, that will be for or. Okay? And means both. Okay? This is very, 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 very important. Or means one of them. Okay? Not necessarily both. For example, imagine that I want to know how many ways of truth would this have. So we do our table of truth, where we label the column p of x, another one q of x, and the last one for this one, right there. Now we write true, true, false, false, and for each one we should have all the possible combinations. That is, a true with a true with a false with a true, a false with a false. Okay? Now we evaluate. To do that, we check. Okay, since we have an and here, and we said that and meant both. Let's see. If p of x is true and q of x is true, then the combination of both should be true. If p of x is true and q of x is false, then, since we said that both should be, this is false. Again here, one's false, one true, so it's false. Both false, it should be false. Now, remember also that this sign right here means negation. That is, when we have p of x, and we have true, true, false, false, when we do this thing right here, we should have the exact opposite. False, false, true, true. Alright? This is important when considering union with another one or an and. For example, a q of x. Here we would say, well, let me go to another page. Let's imagine we have the same problem. This time it's an or, q of x. We do our table. There. We say true, true, false, false. We say false, true, false, true. Yes, yes. Then the negation of p of x, that is the opposite of this column. False, false, true, true. And we evaluate. Since this time we've got an or here, it's one or the other, it doesn't matter. We have both false, so it should be false. One of them is true, since it's an or, this one's true. Okay, this is very important. Don't you miss it when you're presenting your exams, your quizzes. When we have an or with one, it's more than enough for the proposition to be true. This one's true, this one's true. Well, thank you very much for listening to this tutorial. Oscar Romero, and this was Mathematical Logic.